We're now going to look at inverse trigonometric functions. So it's saying that for any one-to-one function, its inverse can be found by reflecting in the line y equals x. So what I'm going to do first of all is just talk about what a one-to-one function is and why it has to be a one-to-one function for our inverse to be found. So if we consider that for any function, for example, f of x equals 3x, we've got a domain, which is the set of values that we put into the function, and then the values that we get out of the function are in the range. So the values of x really is what goes into the domain, and then when we apply the function, that's what's in the range. So we could see that if we put in 2 into our domain, then into this function, what we would do, we'd get a value out once we multiplied it by 3, which would be 6. And if we tried to work out what an inverse function for this one was, we'd get that f minus 1 of x would be equal to x over 3, because we'd have to divide this value here by 3 to take us back to the original value. And this is an example of a one-to-one function, because there's only one value in the domain that will take us to this value here, 6, and there's only one value in the range that will take us back to our original value. And that's why the inverse exists, because when we apply the inverse function, it's guaranteed to take us back to the original value in our domain. If we look at an example now of a many to one, and for this one there's no inverse, so I'll try and explain why there's no inverse. So if we looked at f of x equals x squared, then we'll set up our domain and our range again. So for a value in our domain here of 2, if we square it, then we get to a value in the range, which is going to be 4. So that's all fine so far. But we also know that if we were to put in -2, square a negative number, we'll get a positive answer again. So that will also take us to 4. And the problem with this is then, if we try and find the inverse function, so if we were attempting to find the inverse function, we'd say, well, the opposite to squaring is square rooting. So square root of x. But if we try and square root 4, we don't know whether we're going to get, well, we've got two answers. We've got -2, we've got +2. So that means if we just simply put 4 into our inverse function, we don't know whether we're going to here or here. We can't guarantee that the original value put into the domain is the one that we get back to, because we've got a choice of 2. And that's why the inverse doesn't exist, because for the inverse to exist, we've got to know that we're going to get back to the same value we started off with in the domain. And that doesn't necessarily happen here, because we've got a choice. If we try and now look at how that applies to a sine graph, so we're very familiar with this now. So here's the sine curve, and it obviously continues to plus and minus infinity in terms of the angle, and goes between +1 and -1. So if we were to, so for this function, it would be f of x equals sine x, where x is the angle. So if we put in 30 degrees, into our domain, we put in 30 degrees and apply our function sine x, then we know, hopefully we know, that it's going to give us half. So if we apply sine x, put 30 degrees into our calculator, set on degrees mode, we'll get half as the answer. But the problem is that if we put in 150, because of the repeated nature of the graph, we'll also get half. That would also take us to there. And in fact, we could then repeat it over 360. So that would be 390 degrees. If we put 390 in, that would also take us to there. And we've got an infinite number of values here that would take us to half, because we could continue forever. So what that means is then, if we try and find the inverse function of this, so if we try and find f minus 1, which is on the calculator sine minus 1 of x, actually, if we allow the domain to be all the values of x from minus infinity as the angle up to plus infinity, then we've got a many to one situation. And so if we try and find sine minus 1 of a half, it could be any of these values. What our calculators actually do is they limit the value for the sine to anywhere between 90 degrees and minus 90. So they reduce the range. So that's why when you put this into your calculator, it does actually work, and it will give you the nearest value to 0. So it's reduced the domain from minus 90 to up to plus 90. But the reality is that this is a many to one situation. So for half, if you find sine minus 1 of a half, in fact, we've got a lot of different choices. So the inverse doesn't exist unless we reduce the size of the domain. So if we reduce the size of the domain now, so that it's between 90 or minus 90 and plus 90, then it now looks like this. And what we've now got is we've created a one-to-one function if the domain is reduced to minus 90 up to plus 90. And that domain is better written if I say it as an inequality. So if I write it like this, so we're saying that the domain is this set of values.